All right, here we go. I had a request to go over number 20. You said 20? 22? 20. All right, number 20. All right, guys, we are starting. I need you to quiet down. Thank you. Determine whether the segment lengths form a triangle. If so, is the triangle acute, right, or obtuse? So, 20. We have to check is, so triangle, yes or no? Is 5.3 plus 6.7 greater than 7.8? Check. Is 5.3 plus 7.8 greater than 6.7? Check. And is 6.7 plus 7.8 greater than 5.3? Check. So yes to a triangle. Okay? And again, we talked yesterday. Do I really have to show all of that work? Yes. Yeah, please. Okay? Please do that. I know if you check the two shortest and they work, it will make a triangle. All right? But we start to get into some bad habits, and this happened on the last quiz, where we start to shortcut. Like when I asked you guys to set up proportions last week, and I said, some of you said, hey, can I just find the scale factor and multiply that times the side length to find the missing side? And I said, yeah, that'll work. But what happens if you need to set it up as a proportion and you get it wrong? Like, what's going to happen? You know, so some of you guys didn't quite follow a process, and it kind of stunned me on that. All right. So I'm telling you, this is the process to check for a triangle. And what if one of the sides is missing? 5.3, 6.7, and x. And I said, what could x be? You're going to have to do this process with all three parts to find x, the range for x. So what I'm trying to say is this is good practice for kind of what we could come up to, all right, what we're coming into. Okay. What were you going to ask?
I don't know.
What I just said?
Yeah.
Awesome. All right. So next, it's a triangle. Is it acute, right, or obtuse? Well, this is part 2. So we take the longest side squared and ask ourselves, is that going to be greater than, less than, or equal to 5.3 squared plus 6.7 squared? And I need a calculator. 7.8 squared is 60.84. 5.3 squared plus 6.7 squared is 72.98. Because C squared is less than A squared plus B squared, this is going to be acute. Does that make sense, Chase?
Yeah.
Awesome. Any other questions from that one? Anthony.
Number 22, how do you deal with like the radical form?
Yeah, so what do you think?
I mean, I couldn't
Didn't know?
give a guess.
Okay.
I didn't see myself with that.
What's the longest side between 10, 15, and 5 radical 13? Do you know what 5 radical 13 is? I don't either. So 5 radical 13 is 18.03. So that's the longest side. So first of all, will it make a triangle? Just test it out. And is 10 plus 15 greater than 18.02? 10 plus 15? Is it greater than 18.03? Yeah. Is 15 plus 18.03 greater than 10? Yeah. And that's 15 plus whatever the last one I did not say. Yes, it'll work out. Then what would you put here as the C squared side? 10, 15, or the 5 radical 13?
5 radical 13.
So is 5 radical 13 squared greater than, less than, or equal to 10 squared plus 15 squared? Well, what is 5 radical 13 squared? I'll give you a hint. It's a whole number.
325.
Yeah, and without a calculator, this is going to help us later. Do you recognize this is 5 radical 13 times 5 radical 13? Yes?
Yes.
5 times radical 13 times 5 times radical 13. There's 4 numbers being multiplied. Can I multiply in any order? Yeah, it's a property of multiplication, right? What's 5 times 5? What's radical 13 times radical 13? Someone said it. 13. 25 times 13? 325. Okay. You have to get this. If you weren't sure, quick little exercise. And you might need some, I call them training wheels. All right, you know how when you learn to ride your bike, some of you use training wheels. Unless your parents are hardcore, they just kind of pushed you. All right. All right. What's radical 2 times radical 2? 2. If you need the training wheels, do you agree that's radical 4? Well, what's radical 4? 2, right? We don't really need this step. What's radical 3 times radical 3? 3. What's radical 4 times radical 4? 4. What's radical x times radical x? X. This is why when you do this, watch up here. When you get to here, you can pull a 4 out because you have a pair of 4s, right? What is that? It's radical 4 times radical 4 times radical 5. Isn't that really what this is? And what's radical 4 times radical 4? 4. Radical 5. Now, could you break it down and say 2 times 2, pair of 2s? 2 times 2, pair of 2s. Yeah. Let's take that next step and try to apply it a little bit more. Radical x times radical x is x. That's the definition of what a square root does. A square root times itself is the number underneath, all right? So radical 13 times radical 13, 13. 25 times 13, 325. So here's the moment of truth. Is 320? Ooh, 100 squared or 10 squared 100, 15 squared 225.
Yes.
325 equals 325. What kind of triangle? Right. Any other questions from the homework? All right. I will get into the 9-4-ness. All right, a little bit more. We introduced it yesterday. It's called the tangent ratio. We talked about what trigonometry is, and then we introduced what the tangent ratio is. If you are a very, very visual person and you rely on a process for every single problem you do, you may want to do this. The first time you get to a right triangle in these next couple sections, you may want to label the hypotenuse. First thing, label the hypotenuse, okay? If you feel like you're struggling. This isn't that difficult. I'm just trying to help you avoid common errors, all right? The hypotenuse is always the side across from that 90-degree angle. The tangent ratio never uses the hypotenuse. Because we learned yesterday the tangent ratio is the opposite side divided by the adjacent side. Now, we're going to abbreviate that as opposite over adjacent. Smart Boy's a little glitchy today, so if you have trouble reading that, let me know. What's a ratio? It's the division of two terms, right? So my rule yesterday, by the way, the tangent of an angle, it's always going to be one of the acute angles. So in this triangle, I'm either going to take the tangent of angle A or the tangent of angle B. I have to be told what to do, all right? You'll be told what to do. If it's the tangent of angle A, we put our pencils on angle A, and our ratio is going to be the opposite side over the adjacent side. We talked about this yesterday. Opposite means across from, not touching. What's the only side not touching? Angle A. Side A, little a. So the tangent of angle A is little a, side A, over what's the adjacent side to angle A?
B.
Side B. Again, tangent does not use the hypotenuse. Sine and cosine will. We're not doing that today. We're doing tangent. But I also could take the tangent of angle B. What do you notice about the tangent of angle B? Well, I have to move my pencil up to angle B. Now I'm up here. My pencil's up here now. What's the opposite side to angle B? Across from it is little b, this side. Over, what's the adjacent side? A. And I heard someone say C, and it's okay. We're learning. That's a common mistake. That's why I want you to label the hypotenuse, so you're careful to only use the hypotenuse if you're doing sine or cosine. Tangent will never use that hypotenuse. With me?
Yeah.
That side is called the hypotenuse. It can never be an adjacent side. Never. Hypotenuse will never be the adjacent side. With me? What do you notice about the tangent of A and the tangent of B? Yeah, what's that word? Because opposites, I think of positive and negative. They are reciprocals of each other, aren't they? Good. They're reciprocals of one another. Very good. All right, let's do an example here. Now, we're kind of taking little baby steps here. We're not solving for anything yet. By the time we're done today, we're going to solve for missing sides and triangles. Right now, we're just setting them up. All right? So we're kind of working backwards. Find the tangent of S. Okay, so the tangent, and I like to put parentheses, tangent of S. And I know it's going to be a ratio. And then they ask me for the tangent of R. And it's going to be a ratio. Write each decimal. Nope. Write each answer as a fraction and as a decimal. This is yours labeled down here R?
No, I should.
Are any of them like, yeah. Yeah, thank you. Now, I'll hold off on that. All right, the tangent of S. Where should our pencils go?
On it.
Angle S. What's the tangent ratio? Opposite over adjacent. What's the opposite side from angle S? 80. What's the adjacent side to angle S? 18. There's your ratio. Now, they wanted us to write that as a fraction and as a decimal. Another comment I need to say after grading the quizzes, and I'll pass this back. When I ask you to write something as a fraction, we talked about it. I thought we'd done this before. You know a fraction shouldn't have decimals in it when it's in its reduced form, right? Some of you kind of did that. All right. Yeah. A ratio is a what? It's a fraction of two whole numbers. All right. Which we always did in the review, in the notes, in the homework. All right. We always wrote it as a fraction, reduced. So when we reduce 80/18ths, and just a refresher, because it was a common mistake on the quiz. When you do this, remember your calculator does it for you. 80. Everybody should be doing this. Divided by 18. Okay, my decimal form is 4.4 repeating. 4.4 repeating. My fraction form, I don't touch it. I leave it as 4.4 repeating. I don't hit clear. And I do second. Is it PRB for this calculator? Second PRB. 4 4/9. I don't want that. Second PRB again. Nope. What is it for? I don't use this calculator. Which one is it for this? I only use this one. Anybody have a graphing calculator? I can show you how to do it on there. How do you turn it into a Improper fraction on there.
I just
You
always
don't.
figured it out.
You
I
have
think
to-
you-
I don't think you
I thought you could.
No, it's like a $5 Walmart. They're like $10
I don't know.
All right, so it tells you. Here's what your calculator tells you. It tells you 4 and 4/9. That is, if this were a ratio quiz, you would not write that as your ratio. So what do you have? Next number into an improper fraction.
49.
9 times 4, 36 plus 4, 40. Nice. Are we doing that?
I did that wrong.
If you need to review that, I don't have time to review improper fractions and mixed numbers. You guys need to do that. I'm sorry. All right. No offense. All right. Next, the tangent of R. Ooh. Now we're down at this acute angle. We're down at R. Pencils are on R. And the tangent ratio. The tangent ratio will always be opposite over adjacent. What's the opposite side from angle R? 18 over 80. You'll need your calculator for that decimal, but the fraction, don't overthink it. Let's go to the fraction. What's the ratio of 18 over 80 going to be? 9 over 40, right? 9 over 40. And what's the decimal?
0.225.
0.25?
0.22.
Oh, 0.225. Thank you. And we'll usually round up two decimals. 3 is even better. That's fine. Does everybody understand how to set up the tangent ratio? Did we solve for a missing side in the triangle yet? No, we just practiced writing the tangent ratio. It's a ratio of opposite over adjacent. Okay? All right, next. Find the value of x. So this is our first example. This is exciting. Our first example of finding a missing side in a right triangle using the tangent ratio. Can we use the Pythagorean theorem here? Why not?
Did you have to
You have to have two sides. In a Pythagorean theorem problem, you have to have two sides to find the third, right? This is the problem. We have one side and an acute angle. Okay? Now, if I want to find x, and this is going to be important later, once we introduce sine and cosine, you're going to have to make some decisions. Am I going to use sine? Am I going to use cosine? Am I going to use tangent? All right? And here's what you're going to do. And this is going to be consistent throughout. This is the way I teach it all throughout. Bless you. You know how we put our finger on the acute angle before to use the tangent ratio? We're going to do the same thing. We're going to put our finger on the acute angle we're given. Why? Because we can only have one unknown. Okay? Quick little review. There are 3 parts to a tangent problem. There's the acute angle, an angle. There's an opposite side. There's an adjacent side. There are 3 parts to a tangent ratio. Are you with me? How many unknowns can you have? 1. Okay. Well, if I can only have one unknown, and the unknown is a side, I better use the angle that they gave me. You with me? So here we go. The tangent of our angle, well, the angle is 32 degrees, equals the opposite side divided by the adjacent side. Okay, so from my finger, what is the opposite side? 11. What's the adjacent side? Very good. Now, if this bothered you, you could highlight the hypotenuse to remind yourself, do not use that side because this is tangent. Tangent doesn't use the hypotenuse. All right, a couple things I need to address. 1, it's called the tangent of 32 degrees. This is not multiplication. This is not multiplication. Okay? You know how the square root of 80, it's an operation. It's not times. It's not square root times 80. It's the square root of 80, right? It's an operation. This is a new operation. If you type, and we're not going to do this yet, okay? in solving the problem, but I want you to see the decimal that it is. So if you type, let's go ahead and do it in your calculator. Type in the tangent of 32 and hit enter. Christian, I may need to adjust yours. Did you get 0.625? 0.6248, whatever.
Did you get that, Christian?
What was it? Yeah, so you're gonna get Anybody just have a graphing calculator? I need to help you out. If you have a graphing calculator.
It's still one digit, but it's also the
All right. All eyes up here. Yes. Oh, okay. Oh, yeah. You know what? I introduced yesterday. We didn't actually have the writing notes. Yep, we can do that. Thank you. All right. I need you guys to focus because every year the tangent of 32 creeps people out. Okay. But can we all agree we just typed it in our calculator and it's a number? Yeah. It's a number. So we can treat it like a number. But here's my recommendation. Don't type it in. Now, I typed it in to show you it's a number, but we're not going to actually type that in until the very end. Why? Because we don't want to round and then do another operation and then round again. So how do I get x? How do I solve for x in this problem if it's in the denominator? Multiply, right? Multiply. And some of you may be thinking cross multiply. Isn't this really over 1? So when I cross multiply, I'm going to get x times, write this down, the tangent of 32 equals 1 times 11. So just 11. Cross multiply. Why? Because x was in the denominator. What's my last step to get x by itself? Divide by tangent of 32, because it's a number, right? If it was 5x equals 10, you divide by 5. It's x times the tangent of 32. So we're going to divide both sides by the tangent of 32. So these cancel and make 1. X equals 11 divided by the tangent of 32 degrees. That's what we're going to type in our calculator. 11 divided by the tangent of 32 degrees. We're going to round it to the nearest hundredth, 2 decimal places. Can you help me out?
17.60.
17.60. What is that? That is the missing side in this right triangle. It was the adjacent side to 32. 17.60. Did that make sense? All right. I actually want to do the same problem again. All right. Now, you guys are intelligent students. If this angle is 32 degrees and this is a right triangle, what's this angle up here?
Whatever is left from one.
Good, 58. You guys remember these are always complementary in a right triangle? There's 180. That's 90. These two have to add up to 90. Okay. You ready? I'm going to double check my work. And this is just practice. I'm going to put my finger on the 58 degree angle. We're using tangent again. Why? Because we're trying to find x. X is the what from my finger? Opposite or adjacent? And 11 is the adjacent. So ready? The tangent of 58 degrees equals What was the opposite side? Tangent's always opposite of our adjacent.
17 points.
We don't pretend we don't know that. We're starting fresh with the problem. So x over 11. How do I solve this one?
Do 11 times 50, the tangent.
Yeah. You can imagine this is over 1. If you still want to imagine you're cross multiplying, that's fine. But what happens? 1 times x is x, and 11 times the tangent of 58 will go on our calculator. Surprise, surprise. What do you get? 17.60. Isn't that cool? It's kind of cool. No?
It's just too much work. It's more work.
What's more work?
Doing that.
Oh, I'm not going to make you do that again. I'm not going to make you guys do that. I'm showing you how you could have done that process with either acute angle. I'm trying to show you could have done that. It's going to work out either way. All right? I don't want you to do it twice. All right. I want you to try to set this one up. Now, use the acute angle they gave you. And if you feel confident, go ahead and solve as well.
So, ours is tan of x.
Okay, be ready.
Did you get 25.73?
Yes.
All right. I don't want you to make mistakes, but what do you think some students will do if they make a mistake? Something comes up. What do you think is a common error? Yeah, using the hypotenuse. I agree.
Switching the adjacent and opposite.
Yeah. Accidentally writing adjacent over opposite, but it's opposite over adjacent. It's opposite over adjacent. Okay? Everybody good with that? I do want to get back to the notes, McKenna. I want to get in as many practice problems as we can, so this you guys feel confident with this. Okay? All right, try this one. Did you get 12.19?
Yes.
12.19.
Any questions? Anybody miss it and not know why? You good?
We stop. I know.
All right. Angle of elevation. Angle of elevation or an angle of depression? So this is, I think I've kind of alluded to this in the past, how trigonometry is used in real life all the time. All right, actually quite a bit. Angles of elevation are when you are standing somewhere and you look up at an object. It's your eyes are elevated up to an object. Angle of elevation. If someone or something is up and then from an imaginary horizontal line looks down, that's an angle of depression. It's always from the horizontal line, whether it's an imaginary horizontal line or it's the ground, whatever. It always has to go from the horizontal line. That's the biggest mistake. Angle of depressions get messed up all the time because it's from a horizontal line that's usually imaginary. Okay, like is this line really anywhere in the real world? If an airplane is flying, is there really a line up there? No. It's an imaginary horizontal line, and the pilot looks down. Now, what if there's an ant on the ground, all right, and it looks up? Well, the ground is the horizontal line. It's you can actually visualize it, right? And it looks up. That's the horizontal line, and it's not imaginary. It's actually there. So that's what you have to be careful of, all right? Now, here's our real-life example. If it were not snowing and freezing outside, we would do this. We might do this outside still after the state test. This is kind of a fun activity. We'll walk around outside, go to down to the field and look through the field goal post and a flagpole. It's a fun activity. So we'll do this. And actually, I think I told you this. It's easy enough.
Jackson's so embarrassing.
Or we can sit in here and just do this.
No.
You'd rather walk around? You wouldn't rather walk around?
I would rather walk around. Not something I would do for like leisurely activities.
Who said you're going to do it for leisurely activities?
That's a class thing.
I told you about the tree I had to cut down, right? On my pool?
Yeah.
Oh yeah.
Yeah, I had to do that. Actually, a real life story, Jackson. I'm sure you'll appreciate this since you're so optimistic about all this. All right. Speaking of depression, man, angle of depression. My soul's depressed right now. Jackson, you hurt me.
I'm embarrassed.
I take it back.
So my father-in-law, I used to work for my father-in-law as doing construction in college, and he needed to build. We built like all sorts of stuff, but he needed a wheelchair ramp built to this person's house. And the American Disability Association requires that a wheelchair ramp, I think it's like 6 degrees or less, so it's not too steep for them to go up on the ramp. And we only had so far to go from their driveway up to their front door, all right? And the front door was like 3 feet off the ground. So we could measure, like to the steps, we could measure horizontally how far it was. And then we knew the angle had to be less than 6 degrees. And we wanted to know, is that enough room to make this wheelchair accessible, right? Or not? If not, it got a lot more complicated. We had to do like those like switchbacks, kind of go like that. All right. So it's actually used all the time. And he came up to me. He's like, "Hey, how do I figure this out? Like, He's good at math too. And he's like, how do I figure it out if this is going to be too steep of an angle?" That's the tangent ratio. So these angles of elevation, that's a pretty shallow angle of elevation, but it's still an angle of elevation. These actually apply in real life quite a bit. All right. So if we're going to try to find the height of the tree, aren't we going to use the 59-degree angle? And since we're looking for the opposite side and we have the adjacent side, we're going to use tangent. So the tangent of 59 degrees, which is it? H over 30 or 30 over H? H over 30. Good. Whenever your unknown is in the numerator, it's easy. You just multiply and you're done, right? Because this is always a 1. 1 times h, it's already solved for. 30 times the tangent of 59 goes in our calculator. Yeah, Olivia, if you don't have a calculator for this, you're going to be toast.
I'll get one.
And not the good kind. 49.93 feet. I know it's kind of nerdy. Listen, you guys have to get over that sometimes. All right, Jackson. So it's kind of nerdy, but think about that. If a phone has an angle app, which they do, okay, and you can look up at the tree and say, "Oh, I'm standing 30 feet away." Tape measure. I'm looking up at a 59-degree angle. That's a simple calculation to figure out how tall that tree is. Do you agree? Like, come on. Relatively speaking, if I'm going to say, "Oh, measure that tree," you're like, "Oh my gosh, how am I supposed to measure that tree?" Okay, 30 feet away, 59-degree angle. One multiplication problem, you're done. Can you at least admit for a second that's kind of cool, like in a nerdy way? That's kind of cool. That's all it takes. That's all it takes to find the height of something. Okay. All right, we're gonna run out of time, but that is also. All right, write this down, and then I'll put up the first page of notes that you need to complete your guided notes. How about this? I will freeze this screen. Yeah, I'll do it. Yep. And McKenna, is it this page you needed? Yep. Coming at me quick?
Oh, you did.
I checked this morning.
The chances are it's going to be the exact same.
But you still did good. You still got an A.
Wow. I was wondering because I took mine later. I would have gotten
Oh,
It's gotta be good. They didn't even give you the option. Oh, and so I was like so concerned. And now I understand why. Yeah, now you're back. Yeah,
I didn't miss anything. I was just blank. I only missed one. I was like, I didn't know it was the exact choice. But
There you go, Anthony.
wait, was that maybe that you said you had one thing? You can stay, or you didn't send me pictures. Was that somebody else?